So at today's Google Meet, I went over this problem, and I told you at the Google Meet that I'll go over it again. So if I'm looking at question A, I have that f of x is x squared minus 2x plus k to the negative 1. I'm doing this because it's easier to use the power rule than to use the quotient rule when I get the derivative. Now they're talking about the slope of the tangent line. So f prime of x is negative 1 times x squared minus 2x plus k to the negative 2. Use the chain rule. Remember, k is a constant, so the derivative of any constant is 0. So now I'm interested in the slope of the tangent line at 0. So I get negative 1 times k to the negative 2 times negative 2, which is the same as just 2 over k squared. So we want to know the value of k greater than 0 for which this equals 6, the derivative, the slope of the tangent line. So we get 6k squared equals 2. Therefore, k is the square root of 1/3. Note I didn't write plus or minus because of this detail in the stem of the problem. So I'm looking at question B. I'm going to integrate the integral 1 over x squared minus 2x minus 8. So when I go to integrate this, I'm going to use partial fraction decomposition. I factor this, and then I'm going to take this integrand and I'm going to set it equal to a over x minus 4 and b over x plus 2. I'm going to multiply the entire thing by the GCF, which is x minus 4 times x plus 2. And that gives me 1 equals a times x plus 2 plus b times x minus 4. Now the goal here is to solve for a and b. If I want to solve for a, I'm going to make x equal to 4 because b will cancel. If I want to solve for b, I'll make x equal to negative 2, which will get a to cancel. So let's solve for a first. So I'm going to replace x with 4. So I get 1 equals 6a, therefore a is 1/6. To solve for b, I'm going to make x equal to negative 2. Therefore I have 1 equals negative 6b, so b is negative 1/6. So my new integral, okay, which is just an equivalent integral, this is just an algebraic manipulation, is the integral from 0 to 1 of a over x minus 4 plus b over x plus 2. Okay, when you go to integrate this, you're going to get 1/6 times the ln of the absolute value of x minus 4 minus 1/6 times the ln of the absolute value of x plus 2. There's no problem with u substitution because the coefficient of x is just 1. Remember, if it's not just 1, you need to take that into consideration for your u substitution. So my bounds of integration are 0 to 1. I'm going to sub these in, and then I'm going to stop. There is no benefit to you or anyone, for that matter, to continue after you've subbed in your bounds. So when I sub in 1, I'm going to get a positive 3 minus 1/6 ln. When I sub in 1, I get 3. So those are going to cancel out. But you could just leave them. Doesn't really matter. And then I have my lower bound. So I'm going to get 1/6 times the ln of 4 minus 1/6 times the ln of 2. Just leave it like that. Call it a day. Okay, for part C, I want to show, find the value of the integral from 0 to 2 or show that it diverges. Okay, k is going to be equal to 1. So when I make k equal to 1, my integrand is 1 over x squared minus 2x plus 1. Well, when I factor that, that factors into the square of x minus 1. Okay, so for this is an improper integral. When I taught it to you way back when, I had improper integrals of type 1 and 2. It doesn't matter. You don't need to know which type it is. You just need to know that at 1, we have an issue. Because if you sub in 1, okay, you have an infinite discontinuity. So, to get around that, we're going to go from 0 to 1. And then we're going to go from 1 to 2. All right, if we're traveling toward 1 from 0, we're traveling toward 1 from the left. So we get the limit as a approaches 1 from the left of the integral from 0 to a of 1 over x minus 1 squared. And then as we travel toward 1 in the second integral, we're coming from 2, which means we're coming from the right. 2 is to the right of 1, so I'll make it b. And so that would be b to 2. All right, so when you think about integrating this, okay, you need to keep in mind that if you wanted to do a u sub, you can think of it that way. But, all right, so if I let u equal x minus 1, then du would just be dx. So for my scrap work, this is just all scrap work. I have the integral of u to the negative 2 du. Well, as you know, that's just negative 1 over u. Plus c, of course, because right now this is indefinite. But at any rate, that means that I end up getting negative 1 over x minus 1, because I have to put my u back in. So I get negative 1 over x minus 1. My bounds of integration are 0 to a. Limit as a approaches 1 from the left. Limit as b approaches 1 from the right. And so now when you sub these in, the thing is, if I sub in 1 from the left, right? Think of this. If I'm coming from the left of 1, I'm at a number something like this, right? Okay, of course, we can get closer and closer depending on what we use. But the thing is, if I sub this in and I subtract 1 in this denominator, I need to realize that I get a really tiny, infinitesimally small negative number. But when I divide negative 1 by a really tiny, infinitesimally small negative number, I get infinity, positive infinity. So this is going to diverge. Okay, so the limits do not exist, therefore the integral diverges. Even if one part diverges, the entire thing diverges. Okay, you could feel free to analyze the right one. The right one would just be going to negative infinity because we would use a number such as 1.001. And then when we subtract 1, we get a tiny positive, infinitesimally small number, negative 1, divided by a tiny positive, infinitesimally small number is negative infinity, yada yada. All right, guys, I hope this video helped you, and stay tuned for more. Bye.